Hi, I'm Mike, and welcome to SimWrite webinar. SimWrite is a cloud-based platform for product design powered by simulation techniques. In this webinar, we're going to use SimWrite Simulator to perform a case study for a crane hook. A crane hook is used to lift heavy stuff, and in this case, we're going to find out the maximum load this hook can lift without breaking itself. In other words, without being permanently deformed. Crane hooks are usually made of carbon steel. Here's some mechanical property for carbon steel, and let's just take down the values for elastic modulus, Poisson ratio, and yield strength because they're gonna be used in the later session. And yeah, let's just get started. So this is the website of SimWrite, totally cloud-based. You don't need to download any software. You just need to, register an account, and then you can perform simulation and anywhere as long as you're gonna browse on the internet. All right. So we now have 4 applications. Go to SimWrite Simulator, click Start, upload the file you created. So now the software support two format. After I import the CAD file, see, this is the crane hook I made. So the first thing we're gonna do is to apply the material to the hook. So here's the select tab. It acts as a filter. So basically, like different filter. For example, part. If you select part, you can apply material to the part. If you choose surface, you can do boundary conditions like fixed surface or something. I'm gonna demonstrate later. All right. So here, let me apply the material. This is change the name to carbon steel. The elastic modulus we just took down. It is about. Notice the unit is gigapart. So it's gonna be about 205. So the Poisson ratio is about 0.29. Alright, so see the color changes, meaning like we have successfully applied material to the CAD model. The next thing we're gonna do is to, alright, I'm gonna choose, boundary conditions. Let me fix this surface because we don't really care like what happened above, we only cares about the lower part of the model. So let's just make the surface fix. Yeah, you can rename it or you just keep the default name and note it. Just note like all directions are all checkboxes are pre-selected. So okay, the final step is we're gonna apply a load. Let me just choose the point load. Right click and load. So here's the dialog. You can change the value of the force. Please notice that here's the Cartesian coordinates. Basically, the force should be pointing down, right? Just like the gravity. So the force, let's just assume about 10,000 Newton. Here's the default unit. Alright, so here we apply everything, let's just click the control panel. So it's gonna take a few seconds. Alright. So here's the default result page. As you can see, like this is the from the legend. You can see this is the displacement diagram. let's start from the beginning. Like, so let's see the stress. So the stress is like 20, 23, 24 megapart, which is like far less than the yield stress, which is 280 something. So this is gonna definitely work. Like it can definitely lift like 10,000 Newton. Also, let me show something cool. If you click Contour plus Deform, you will see the deformed shape, deformed CAD model. Like those outlines, the black outlines here are the ones that basically the undeformed shape. Basically, you can see like how much the shape is gonna off after applying a force on it. And when you see the control panel, here's the deformed scale. Like it's automatically like scaled so that you can see clearly like what's the deformed shape gonna be look like when compared with undeformed one. Okay. Also from the legend you can see here's the displacement. And for example, if you wanna change some of the conditions, you can just go back to the setup. You will just go back to the setup page and you can basically edit. For example, you may want to like change the material. Basically, you can just change the value of it and it will automatically apply after you click OK. For example, if you want to change the load, for example, maybe you want to change the direction, like it's not pointing down, but instead pointing up. See, let the direction change. If you click solve again, now instead of deformed pointing down, it's going up. All right, that's pretty much the webinar, and thank you for your attending. Thank you.